Good day, everyone. Good day. Just want to revise with you 2024 GCE Science Paper 2, question 5 under stoichiometry. So this question reads 10.5 grams of sodium hydroxide was reacted with dilute sulfuric acid. So this is dilute sulfuric acid according to the equation. We've got sodium hydroxide plus sulfuric acid, which is dilute, which will give us sodium sulfate plus water. Now, the first one is balance the given equation. Then after we do that, B1, use the balanced chemical equation to calculate the mass of sodium sulfate formed. Then the last one is what type of reaction occurs, what type of reaction is involved in the equation. So let's answer. First thing, we are going to balance the given equation. So here we are asked to balance this equation. So what we do, just copy first what we have. We've got sodium hydroxide, it is in aqueous state, then plus sulfuric, which is also in aqueous, which will give us sodium, sodium sulfate, which is a salt, then plus H2O, which is liquid. So we just need to check. So you check how many sodium do you have this side. We've got 1, then this side we've got 2. So now in order for us to balance, there we've got 2, there we've got 1. So here, which means we are going to add 2. So it means this sodium and this sodium is what? Balanced. Then apart from that, we have oxygen. How many oxygen do we have? So here we've got 2, this 2 oxygen, and this 4. So altogether we've got 8. Then this side we only have 4. And this one there we have 5. So in order for us to balance, then again we have hydrogen 2, then hydrogen 2. So there we've got 4. This side we've got only the 2 hydrogen. So we add 2 this side. Then just checking this, you find that this equation is already what? Balanced. So we've balanced the equation. So there we'll give, or 1 mark is going to be awarded just for balancing the equation. Okay, so now we go to B1. Use the balanced chemical equation to calculate the mass of sodium sulfate formed. Yeah, so here we've got different types of methods that we can use, which can be, mass to mass ratio, or we can use another one. So I'll use the first one. We need to find the moles of what I've been given is sodium hydroxide. So let's find the moles of sodium hydroxide. So the moles of sodium hydroxide, first thing, you consider this equation, but here we are told that we need to use the balanced one, whereby this 2 is going to be what applicable when answering. So what we are going to do, we'll use this one first, which is sodium hydroxide. So we find the molar, because what I want here first to find is the mole, which is N is equal to mass then over molar mass, which is molar mass. So molar mass, we'll say hydrogen there it's 1 times 1, then oxygen there it's 1 by 16, then sodium there it's 1 by 23. That is the mass numbers. So whatever that you are going to do here, what you are going to do, you multiply, then you add this, you get 40. So once you get 40, you just replace there. So you are going to replace here where there is smaller mass. Where there is mass, you replace by the one that you have been given to be 10.5. So this 10.5 here is the one that is going to be our mass for sodium. So what we are calculating here is the moles of sodium hydroxide. So we'll say N is equal to 10.5 then over 40, which is this is what grams, there is grams per mole. Yeah, so it's gram per mole. So what happens is when you do your calculation, this one into this one into this, first thing you can cancel there. So your mole here for sodium, N is equal to give us 0.2625, which is moles of sodium, which is sodium hydroxide. So having this more sodium hydroxide, which means we are going to use this ratio, since they are in the same equation, when this one reacts with this one, it's going to give you what? This one. So here we are going to just to equate this one and to this one, so that we may find the moles also for sodium sulfate. Yes, sodium sulfate. So what we'll do is we'll say moles of sodium sulfate. So we'll just say here we've got this. We are using the balanced equation now. So we've got this one, which is, so we'll just say N there, which is representing the moles of sodium, okay, sodium hydroxide. Then you consider the coefficient, which is 2 down, which is equal to, what do we have there? We are calculating the moles of this, so we'll say N, it is moles of sodium sulfate, okay, sodium sulfate. And then we don't have any, so here the coefficient is simply 1. Then you replace here, we're going to put the moles of this sodium hydroxide that we've calculated to be. So here it's going to be 0.2625, then over 2, then is equal to N. So here we just have N. We know that we are calculating for sodium sulfate, so we have N, whatever that you are going to do, over 1, then you multiply this and this, and then you divide by that. It's going to be our N is equal to, this one is 0 point, there it's 1, then 3, this side it's 1 again, then 5, 2, 5, which is moles of sodium sulfate. So this is the mole of sodium sulfate. So having this mole of sodium sulfate, then we can also calculate the mass. So calculating the mass, we are just our N, we say N, which is mole is equal to mass, then over molar mass. So like this. Then we are going to find the molar mass for sodium sulfate. So molar mass for sodium sulfate, we know to say that once we write like this, Na, yes, there's 2, then sulfate like this. This one will be 4 times 16, then this one will be 1 by 32, then this one will be 2 by 23. So once you do the calculation, once you do your calculation there, you are going to have 142, because this is 64 plus 78. When you add this, you are going to have 78 plus 64, you are going to have 142. So 142 as your molar mass. So having that 142 as your molar mass, there you replace by this more, which is 1, so the 0.13125, then is equal to mass. We are calculating mass over, we have 142, okay, 142, which is for this one. So for this one, so we just multiply here this and this. What do you get? So once you multiply this times that, you get your mass to be M is equal to 18.6375, which is gram. So having this gram, so what you do, you can round off to 1 decimal point or to 2 decimal point. So if you want to round off this to 2 decimal places, which means this 7, it will give 1 to 3, and then it's going to be 18.64. So now I'll give this to 1 decimal point, whereby you are going to have M is equal to 18.6 grams of sodium sulfate. So this is what will be formed. This is what will be formed. So what will be formed here, we are saying that it is 18.4 gram of sodium sulfate will be formed after you've done all your calculations. Yes, I know that this type of or method can be confusing, but if you want, you can use the mass to mass ratio, so that you are able to to answer in that way. Yes, you're able to answer in that way, but you need to know all the ways in which you can reach at the same answer. Okay, thank you. So now we continue. What type of reaction is involved in the equation? So here we just need to know that when a base and an acid react, the type of reaction, it is what we call neutralization, because the salt is being formed and water, which is neutral, water is being formed, and here water, we know that it is neutral. The pH value of water is 7. So which means the type of reaction is neutralization. So we say neutralization. Okay, thank you.